Okay. Yeah, I guess we are recording. Okay. All set. Okay. First of all, welcome Siddha for this 13th episode on machine learning for beginners. And first of all, thanks a lot for taking the time out of for this. I know you have been really busy with your a few projects that you have been working on over at your workplace, and Sunday is definitely not a good time to ping someone to for this kind of webinar. So thanks a lot for doing that. And before I shift on to Siddha and her experiences and her interests, I'll just take a few minutes to explain what this channel is about and about a bit about myself for the people who are visiting this channel for the very first time. I create these videos and I maintain this channel for people who are new to the domain of machine learning, and they just really want to figure out what exactly lies in this domain and what really to expect. And I normally try and invite people like Siddha who have been really quite successful in this domain of machine learning, and who can share really great insights, what really to expect and what it takes to be there. So, just a bit about myself is I'm a PhD student at Arizona State University doing my research and building interpretable AI models for medical diagnosis. But I'll shift on to Siddha as of now to talk more about her. So Siddha, can you tell us a bit about yourself and few things about your research interests, and what are you working on, and what has been your background?
Sure, that would be my pleasure. First of all, thank you so much for inviting me. Hey, everyone. It's really nice to be here to talk about some of my work and to help the next upcoming generation do their bit. So currently, I'm a self-driving car architect at NVIDIA. And as you can imagine, it entails a lot of figuring out from a computer vision aspect what the car is seeing. So what makes a stop sign look like a stop sign? And once the car knows what a stop sign looks like, how does it figure out what the next action is? So it involves a lot of training, simulation for improving the accuracy of the neural networks. And as far as simulation comes in, there is only so much real world data that we can collect, because drivers inherently are safe. And, because of simulation, we get to collect all possible scenarios and we get to simulate the neural networks. And that's really a really interesting bit of working on self-driving cars. So that's really what I do at NVIDIA. In my free time, I also help out in some projects with the FTL, which is a AI accelerator within NASA. And I go back year after year to try to figure out, what new can I learn about physics and space, and how can AI help in those areas. So that's a little about me.
Yeah, I'm sure that there's a lot of things still. I mean, I guess you would be shy to tell things about, but I know you have been also featured on the Forbes 30 and the 30 list in 2019. So first of all, congratulations for that, and that's a big feat of achievement in itself. Uh, but talking about, like, you have been, so what has been your outburst in the whole domain of machine learning? So how did you get started into domain of machine learning? Was it something in undergrad, or was it something in your grad study or internships? What was the thing that when was the time, I would really ask, is you felt that, okay, machine learning is something really cool, computer vision is really cool, and how did you take forward from that?
Yeah. So before I actually start answering that question, I want to say that, I want to preface this with a disclaimer that whatever I'm going to say are going to be my own views, and they're not affiliated with any organization that I'm a part of. And so when I look back, when I started learning about what AI is and what machine learning is and what data science is, I think it was back during my college. So back in 2011, I started my bachelor's at NIT Hamidpur. And so as you can imagine, back then we did not have any machine learning course, right? So I really started trying to do things hands-on. And I think the root cause of that was that I used to go to a lot of hackathons back in college. And hackathons are a very practical kind of an atmosphere. It's like a sandbox where you have 24 hours to try something out, or 48 hours to try something out. And I think that's really where the more practical aspect of computer science really appealed to me. And oh, this is interesting. So back in 2011, Windows Phone development was a thing, right? Nokia phone, application phone development was a really important thing. And I remember my very first hackathon was sponsored by Microsoft Phone, Windows Phone, and Nokia. And so we had to develop applications for that platform. And as you can imagine, mobile phones weren't as mainstream. So mobile application development wasn't as mainstream either. So this was really my first foray into understanding what mobile application development was. And surprise, surprise, what a genius and innovative mind I was. I figured out that a calculator would be the easiest thing to build. And that's what I really built. But the atmosphere of the hackathons are very interesting, right? Because you can easily find mentors. If you have an issue, you can go and ask someone to help. And at least my personal experience has been that people are always willing to help out. And so I think that's where I was able to figure out that mentorship is really important. And so eventually, a year later in 2012, when Coursera came out, and then MOOCs started, becoming more mainstream, and then the machine learning course by Andrew Ng came out. And again, I didn't have any background in machine learning or AI or anything in that domain back in 2012. So I started out this course, and throughout, I used to look for mentors at hackathons or at all these different places, or even my college professors. And I would just ask them all these questions that I had. And I think that really helped me figure out what I really liked. And, similar to AI, I tried out almost like all the domains that we have in computer science: networking, system administration, databases. And I feel that I really liked the AI bit when I tried it out. And I think that's why I've stuck to it for a longer duration of time. And we'll see how that goes.
Yeah, no, definitely. I mean, AI has really great potentials at least in the next few years, for sure, before the deep learning winter is really expected. But I guess it has a good potential.
Winter is always coming.
Yeah, definitely.
Yeah.
But yeah, if I were to connect as a person who would see your profile as you have been like you shifted from you have worked at a pretty diverse set of places, but pretty much interconnected. You have worked in a physics laboratory setting at CERN, but eventually you are also collaborating with NASA, which somewhere relates and might really have built a kind of a base of your profile, and doing masters in alongside that, and working at DeepVision and currently at NVIDIA AI are some kind of like building blocks of a tree that I can see that, okay, you started out small and kind of interconnected at a higher level of the science architecture. How would you relate how would you relate your experience of grad study, like how much importance is grad education really in this particular aspect of making up your profile, and how really have you learned from internships? Like, was it something very crucial? You would say that, okay, without internships and without grad study, I would not have done this kind of thing? Or is it something like, okay, maybe I would have done, or maybe, oh, master's was totally a waste of time and money? Like, how would you rate your experience of internships and grad study?
That's a really difficult question, because in retrospect, I can't say what worked or what didn't work, but I know that when everything comes together, something worked, right? Something out of the bag actually worked. But education in general is really, really important. Having a good theoretical understanding of what we're doing. And then on top of that, actually having the practical component of it, like doing implementations, doing projects really, really helps. And again, that's something that I really learned from my hackathons, right? Knowing an algorithm is good. For example, in the calculator bit, right? knowing about precision and multiplication is really good, but actually implementing it when you're building a calculator is where the practical component stands out. So I've always felt that the practical applications of things really stand out. And that's something that is relevant in the academia, in the industry, as well as internships, because people are required to do the the practical bits, to the implementation bits. And so that experience is really relevant. I'm not sure if that's answering the question right on, but I mean, education is always important, but having the practical aspects of it are relevant as well. And going for a master's or not going for a master's is an individual decision. I can't really say anything to that, but it's always good to understand what different viewpoints are for every subject. Like even for computer vision or machine learning or anything, it's interesting to see how different people can talk about machine learning in the same way. For example, there are two courses that are available online. One is by Professor Yasser from Caltech. That course is on YouTube. And then there's another course, for example, the Andrew Ng's course on Coursera, right? They both talk about machine learning, but they talk about it very differently. Professor Yasser's one is very theoretical. And of course, there is a practical bit to it as well. But the way he explains equations, and it's a very beautiful, beautiful way that he explains it. But then Andrew Ng adds a lot of data component to it. So it's very different.
Yeah, I guess the bottom line being is, of course, theoretical foundations are really important, but it's really important to get a practical aspect, and how really things pan out in the industry is critical.
Absolutely.
So, yeah. And one other question that I personally also have, and I guess the people watching this video might also have, is if I pick any domain of AI, be it NLP, reinforcement learning, computer vision, it changes every damn day. Like if I open Twitter, there is some scientist publishing some work and it's making a great impact. And so how do you personally, like, okay, if you are working at NVIDIA AI, is maybe computer vision might be a really crucial aspect of your life and your implementations. How do you, or over the time at your grad study at CMU, how did you yourself personally had the habits of keeping yourself updated to the latest developments? Was it Twitter? Was it Google Scholar? Was it something else? What was your habit and to-do lists for that?
So in grad school, I started joining a lot of reading groups. And a reading group is basically either you have one paper and you present it, or everybody reads the same paper and we talk about it. So either way, you either get different viewpoints on the same paper, or you read one paper, but you ultimately get an understanding of 10 papers because everybody's presenting some paper. But at the end of the day, reading groups is a really good way to sort of collaborate and understand what's really going out in the research field. And so now I look at, for example, TWIML AI has a lot of reading groups. They talk a lot about publications that come out. And similar to TWIML AI, and TWIML AI is This Week in Machine Learning and AI. It's a popular podcast. Then there are similar newsletters which comes out. For example, O'Reilly has a newsletter that talks about some recent publications. Then The Batch is one, it's by deeplearning.ai. And then there are so many so many newsletters which come out every now and then. And then there's also something called, it's a website called Shot Science, where people actually put out snippets of papers. And when you're doing research and you want to go into breadth of all the papers that are available out there, Shot Science is a really good way, because it, people have put out like small paragraphs describing each paper. So in the 5 hours that I can spend reading one paper, I can actually spend reading 500 papers. So it's a really good way of sort of collaborating and aggregating all the knowledge that's out there.
That's really interesting. Yeah, definitely. I will also definitely check out these particular resources. But yeah, definitely talking about resources. I recently figured out you also wrote a book on a certain application of AI and cloud. So like, I'll let you describe the whole reason. But what I really want to know is what is the really book about and what really motivated you to write a book for this particular? Because writing a book this early at a stage of life is really a great feat of achievement in itself. And I know it has been getting a lot of reviews on that particular book, so it's doing really well. So I want to know two aspects: what the really book is about, and who is it really helpful for, and what really motivated you to write a book. I mean, yeah, it's hard for me to even complete reading a book, and wrote a book, so I'll definitely want to learn more about that.
So when I graduated, I started going to a lot of conferences. And again, conferences was another way to keep up with what's going on in the industry. But I also used to, give talks about some of the work and some of the projects that I was working on, which involved AI. And during these conferences, I noticed that there was a difference in applied AI knowledge versus what is being taught in there's a difference between the more practical aspects of AI and theoretical aspects of AI. And the book really came out as a way of that. And as I mentioned before, I used to go to a lot of hackathons. And one thing that hackathons teach us is if you can do something in 1 hour, how would you do it in the best way possible? Versus if you have a day to do it, how would you do it in the best way possible? And that's really how we've put the backbone of the book to be. So for example, if you have to build a reverse image search engine, how would you go about building it in an hour? If you had a day to do it, how would you do it in a day? And if you had to build something at like Google scale or Pinterest scale or Wayfair scale, which takes years and years of effort, how would you sort of weigh each embedding of the image? How would you make sure that it's 5 nines reliant versus 3 nines reliant, and go into all the implementation aspects that are really relevant in the industry. And I think one more thing that really motivated me was that people used to ask, how do they really develop their profile during their bachelor's? And I realized that we needed a way to somehow democratize AI knowledge that was more freely available than applying for colleges and getting that knowledge through there. It needed to be more mainstream and more widespread. And I think the book really came out as a way of that, to help democratize the AI knowledge and help people understand the more practical aspects. Because in a lot of theory courses, theory is the main focus and not the practical implementation side of it. So that's what the book is really about. And it's the audience is really people who are interested in AI. The book doesn't assume that you have an AI background, but you have a curiosity, sense of curiosity that will motivate you to keep reading on and on. And the good thing is that we've put out all the code out on GitHub, and it's easily runnable through Colab notebooks. So you don't really have to go through that 2-3 hours of setting up your systems and installing this framework and that framework. So we've tried to make it as easy as possible. Yeah.
Wow. Yeah, that's really interesting. And yeah, I mean, I have been following your conversations over here, and you talk a lot about theoretical knowledge versus practical knowledge, and you have kind of indulged yourself and not limited yourself to the theory aspect of computer vision and AI. If I can ask is, what is your ideal workday routine over here at NVIDIA AI? So I'll ask from a very student perspective. Me being a research student as for a bit longer time is, we normally have projects and normally some kind of theory applications that we want to improve the accuracy numbers on that, like we want to improve the state of art results, and we go on implementing the latest model out there if it is available. And we do a very kind of a cumbersome work on research, and maybe at the end write a paper about it. But I'm sure it differs from ER applications. So what are like, for example, what frameworks do you use? Like, is it something like PyTorch, TensorFlow? How do you, like, what does your day routine or week routine or month routine, sprint routine looks like? Do you implement models straight away? Do you code a lot, like drink coffee? Or is it something like that? Or is it much more managing other aspects of industry related research? I don't know. I don't even have the ideas to ask a question, but like, what is a day routine? Like, what is an ideal routine of a self-driving architect at NVIDIA?
It would be interesting if we could just drink coffee and everything would just happen automatically. But the funny thing is that I don't even drink coffee, and the work just happens automatically. But
magic.
Yeah. So anyway, of course there are like sprint cycles, but similar to what you said, even in academia and in your PhD life, we do have, you know, multiple projects that we are focusing on, and there are more sort of practically relevant aspects to it, like how do you make your code run on multiple cores, or how do you make your code run on multi-node, multi-GPU systems? Is it scalable? How do you inculcate traceability into it? How do you inculcate explainability into it? And so all these sort of industrial level questions we have to ask before we go about implementing anything. And I think apart from that, a lot of it stays the same. Like you still have to code. When it comes to frameworks, I prefer to use NGC, which is NVIDIA's GPU containers, which is basically more optimized for the target hardware. So if I'm running some task on a V100 for TensorFlow, I'll download that particular NGC container for it. And similar to, you know, whatever I'm doing, I'll download the relevant NGC container. And from a more practical aspect, it's really easy when someone else is doing the setup for you and you just have to run something, right? And it makes it really easy and really lowers the bar to, you know, get up and running quickly.
Awesome. Yeah, that makes sense, definitely. And yeah, coming to the most interesting section of this particular interview that I normally like to ask people is, what according to you, I know this would be a biased view based on your particular work of interest and research interest, is what do you see the trend of AI? Because I mean, me being a very recent student graduating out of my undergrad and completing my grad, I have seen a lot of phase shift in the whole domain of AI. Like, I mean, every day you wake up, it's a different thing people have been targeting on. So working with NASA, I mean, that is a kind of a leader in the science, and they pretty much pull a lot of resources of young engineers, and also NVIDIA, which is on the top of the stack. What do you see the trends of AI? Like, me being a student, where should I focus my effort on? What should I focus my thesis on to be much more relevant after 5 years? So what are the trends? I know it might be specific to computer vision and maybe not NLP and reinforcement learning, but in general, if you have any ideas, like you might be following a lot of places, what do you think might be a good thing to invest one's knowledge in 2020?
That's a good question. And I think in general, it's always good to know, like if you think about it from a pipeline perspective, right? It's always good to know everything that's happening inside the pipeline. But at the same time, one cannot have expertise in everything that's happening inside the pipeline. So it's good to concentrate on one thing, but know absolutely everything that's happening inside it. And so similar to that, in AI, we have a lot of things that are happening, right? For example, how do we figure out bias in the data that we have? How do we make sure that our models are more explainable? How do we inculcate ethics and privacy in the models and in the way we are shipping the models? So all these are very relevant questions, and they are becoming even more relevant as AI models become more mainstream in things that we do. And, you know, it's difficult to say that you should pick one and concentrate on that, because, I mean, that's not really how you can move forward. You need to know everything, right? It's like you're driving a car and you say, okay, I just want to learn how to change the gear. but that's not going to work. You need to know absolutely everything. So I know it's difficult, but one has to do it. Yeah.
Right, right. Yeah, definitely. I definitely can relate to that particular thing. So yeah, and one like you were talking about, like one has to relate to many things. That puts me to a next question that I also had, which is much more specific to you in general.
Mm-hmm.
Is if I were to follow your profile, you have been working at a very different and diverse set of workplaces. So, being at CERN, which is much more a theoretical, sciencey foundation to work with, but still they are on the top of a stack of implementing AI and using deep learning for a different aspect, which is not computer sciencey. You worked at DeepVision, which is comparatively a smaller startup, but still very ambitious in its particular domain. And you have worked at NVIDIA, which is definitely on the top of stack. And now you're working with NASA, which is a different set of workplace than the normal computer science thing. But assuming that, okay, you figured out all of your computer science knowledge, all your computer vision and AI things, but there are some subtle things that you might have learned working over there at different places, like some workplace dynamics and all those things, like how to work and how to collaborate with people, which is itself, like, I mean, I have seen people taking a lifetime to understand how to collaborate with people and not just work on their own. And it's highly relevant for us as computer science engineers and programmers. So how do you, what kind of light insights you might have is like, what different thing deep vision offered you from NVIDIA AI, or maybe what NASA taught you something different than CERN, and how CMU was different than maybe NIT. Like, just I know it's a big question to ask, but just some kind of light insights if you have, like, over the, if you were to drift over your timeline, what would it be?
You know, when I thought about this interview, I didn't realize that all questions are going to be super difficult.
Yeah.
So, of course, different organizations are built differently, right? Like a startup is very different in terms of the work that I did and in terms of the entire stack that I got to be a part of, versus at NVIDIA, where, you know, it's a very small area that I'm working in. I mean, NVIDIA is a big company. They have work in computer acceleration, GPUs, graphics, healthcare, and so on. And, you know, I'm a very tiny aspect of it. But in the startup, there were like 5 of us, I think. And we were working on a very, like, the entire focus of the company was a very small thing, which in itself is pretty big, but everybody was concentrated towards that. So that was different. Then at CERN, it is a laboratory at the end of the day, but I personally didn't get the opportunity to, you know, put magnets in the system or just do anything that was actually that hands-on. Because of course, at the end of the day, I know a little bit about computer science and I don't know a lot about physics and all the stuff that goes on in their experiments. But it's always fun to have a curious mind and to ask questions. For example, even at the project with which I'm volunteering at FDL at NASA, which is the Frontier Development Lab, it's trying to figure out what patterns are there in solar storms. Now, I, for one, don't even know what solar storms are. So figuring that out in itself, I think, is a great learning opportunity for me. And so, yeah, I mean, having a curious mind and being open to knowledge, I think that is very relevant.
Yeah, that makes sense. That makes sense, definitely. And yeah, I guess I just have one last question that I have, which can be broadened to as much as you want, is because I have observed this channel particularly, most of the people who are watching this channel is pretty much people who are trying to make their career in machine learning, being mostly most of them are being undergrad in some universities. What kind of advice that you might have is, you might have learned over the time that there are strict do's and maybe strict don'ts, that okay, stay away from this if you want to get ahead and speed up your profile, or like just don't get stuck into this particular myth of developing your career as an ML profile,
Hmm.
what would you suggest? And because you have gradually accelerated on this particular domain from like you said, in our undergrad we don't have a huge outburst in the whole machine learning AI domain. It's pretty much we trying to move out of our way, like doing MOOCs and all those online courses, but you gradually shifted through from CMU, I guess you accelerated a lot. So what would you suggest anyone out there? Like, should they focus on theory first, or should they do practical first, or should they do a bit of both? Like some kind of those tips that they can really like what would be that to-do list on every morning? Like, okay,
Wow.
I need to do this because Siddha said that.
So
Yeah,
very
something like that.
prescriptive. I think theory and practical implementation go hand in hand, right? Like everybody knows eating healthy is important, but unless you actually do it, it's not going to help you. So keeping that in mind, I would also say you should make plans for whatever projects you have, or whatever goals you have in mind. And once you have a plan, everybody should always plan for success, but it's not always that everybody succeeds. So always have a contingency plan and recalibrate when you fail. And this is something that I've also experimented and I've tried to stick to throughout my career. What else? I think, again, having an open mind and being curious, asking questions, asking for help, asking for mentors, getting mentorship, and of course, hard work. It's undeniable that you have to do hard work. And I think one more thing that I've seen a lot is that because AI is the hype, right? You shouldn't feel like, okay, because everybody's doing AI, I also want to do AI. And I think there are a lot of people who just get into it because of that. And when you think about it, and when you ask them questions like, oh, hey, you implemented SST, tell me more about the network, and they're not able to answer those questions. So don't be in a position where you have sort of a surface knowledge or a more like a glossy knowledge, but actually go deep dive into what you know, what you've done, and be comfortable talking about it. I think that's really important as well.
Right, right. Yeah, I guess, yeah, the intrinsic motivation is really greater than the extrinsic motivation. I guess that's
Yeah.
the thumb rule of research.
Yeah.
So, yeah, yeah. I guess, yeah, that's pretty much I had for this particular interview plan. I guess it covers most of the topics. I don't know if I really missed anything, but I'll open it to you. Like, do you have anything in general? I mean, I will be linking your link to the book that you have wrote in the description below, and I guess I'll also link your LinkedIn profile so that people can reach out to you if they have any specific questions. But yeah, I guess if like I don't know if you have any words other to share, or else I can conclude the video.
I'm good.
Okay. Yeah, awesome, awesome. And once again, thanks a lot, because I know, again, I need to apologize and also say thanks at the same time for me picking your time on a Sunday. So,
That's perfectly fine. That's okay.
so yeah,
It's a
but
pandemic
thanks.
anyways. I can't go out.
Yeah, that has been really helpful for
Yeah.
me to. So yeah, definitely. So yeah, thanks a lot. Thanks a lot for sharing these insights. Hopefully they are really helpful for people who are watching this video, and also personally to
Absolutely.
me, they have been really helpful. So yeah,
Yeah.
thanks.
Thank you.